Alrighty, guys, welcome. So I'm going to go over a couple things that you might want to know for your airfoil project for your Vortex panel code. I guess just to start, so I guess to give you a brief overview, what we're trying to do is we're trying to understand the lift and drag and a couple other things. Well, I guess not really the drag, but the lift on an airfoil. And so what we're doing is we're taking these points around an airfoil and we're trying to determine, we're trying to assume that there's vortex panels, and there's videos on that you can read about. So I just want to go over a few of the coding tips and tricks that you would need in order to do the project. So I wanted to start out by doing how to read in a file. So in Python, what we do is we need to import libraries. So I'm going to go over Numpy. I'm going to go over matplotlib. Let's see, matplotlib dot pyplot as TLT. And then we're going to do JSON. So JSON is basically a way to read in a dictionary, but I'll go over that in a minute. So in order to read in a file in Python, we have to start off with opening up the file name. So say we have this file right here. So this is the 10 data points for the 2412. What you do is first you have to initialize the file name, right? 2412 underscore 10 points .txt. Okay. And so what we can do now is we can open it. So with open, so that's just the basic function call in Python to open a file. And we have to read it in, so that's what the R value is for. So now we can go through the file. Since it's just an array of points, it's pretty easy. What we're going to do is we're going to read in each of these as a string, each of these lines as a string, and then just split it based on spaces. So we can do, well, first we have to initialize a list. So a list is the basic array-like data package, I don't know what to call it, in Python. And so we can initialize a list as this. And so now what we can do is we can go through each line of the file and we can pull out the information that we need. So we'll do a for loop. So for line in the file F, we're going to split the line, and then we'll add it to info. So info.append, and then we create a list of the values. So that's what these brackets are for. We create a list of the values, and we create a float of each value in that list. And since we're not giving it any value to split it on, it's just going to split it based on spaces. So now we have an info list that is going to be, well, we could just print it out just so you can see what it looks like. But first, I should close the file. Okay. So now we can run the file. Let's see. That's not what I want. I want to say Terra_GTA and Python crash course. So if you've never even touched Python before, you're going to need to install a Python compiler. You can do that through downloading Anaconda. It's free. It's a package that has a lot of a lot of these libraries already within it, so you don't need to worry about downloading these. They come with Anaconda. That's what I would recommend. And I believe Anaconda even comes with Spider, which is an IDE that a lot of people use. I use Visual Studio Code, completely up to you, whatever you want to use. So let's go ahead and print out info. And we've got a problem with our directory. Well, that's new. 2412_10_pt. That typos, man, they'll get you. IO operation on closed file. Oh, yeah, I'm telling you, man. You should never code early in the morning. Okay, so now we've got this array of points. Okay, so we can kind of see, and you can definitely use lists. I'm going to go over why you would want to do Numpy arrays. Lists are slower. They do allow you to initialize data. So for any of you that know much about C++ or something like that, a list, I can just say, hey, I just want a blank list, and then I want to add values to it. With a Numpy array, you can't really do that. There are append functions that you can have, but it's just easier if you initialize it with the set value that you're looking for. And I'll go over that in a minute. Okay, so that's how you read in a value, or excuse me, how you read in a file. And if we wanted to turn this into a Numpy array, it's actually pretty slick. As NP. And I would also recommend make sure you comment everything in your code. I mean, you're going to kill yourself if you try to go back, you know, a week later or something like that, or even days later, and you're just, what in the world was I doing here? Comment out everything. Makes your life so much easier. Okay, so we can turn it into a Numpy array. It's actually pretty easy. So info is equal to numpy.array of info, right? That's pretty easy. And now if we print out info, that's a Numpy array. So you can kind of see, I mean, there's literally no difference between it. I just made it so that the data is a lot more accessible, for me at least. And once again, you're welcome to do whatever you want, but I vote Numpy arrays. Okay, so that's how you read in a file. So now we've got this 2D array of values, and you can see that the first column, actually this is an important point to bring up. Dr. Hemsicker brought this up too. In Python, zero indexing. We have zero-based indexing. So that means that this is 0, 0. This is 0, 1. Or excuse me, that's 1, 0. This is 2, 0. This is 3, 0, and so on, so forth. So this first column is the x values. The second column is the y values, okay? So now that we have this array, and I could just show you how to work with that. So we could print out the x values. And it's pretty easy in Python. You just print info, and that semicolon, or excuse me, that colon means every value in that array at the 0th column. So every row for the 0th column, it's going to print it out. And look at that. We've got all the x values right there. And we could do the same for the y values if we wanted. Boom. Okay, so if you'll take a look at your, I had it open. Oh, this is it, dir. You're going to want to set it up so you can read in a JSON file. So a JSON file is simply, let me create a new file, JSON input.json. I'll copy and paste that in here. And let me format it real quick. Okay. So a JSON file is just a way to read in a dictionary. So usually we use text files for data or CSVs or whatever, but JSON files are really handy if we just want to read in variables, and it's really nice if you're going to end up doing an object-oriented code. But so this is the JSON file, right? So I'll comment that out. So this is what this library is for, the JSON file. And I've got to remember to talk about plotting. I don't remember whether you guys are required to plot for this. You might want to know it just so you can look at your airfoil, make sure you're plotting them correctly or using them correctly. So I'll go over that. So reading in a JSON file, so that's extremely important because these are variables that you don't really want to hard code in just to make your code a little bit more usable. So what we can do is, now that we've got JSON imported, what we first do is we create a JSON string. So we just basically read that file and create a string out of it. And then we open, so this is something I need to do. So let's initialize the file name. I'll do JSON file is equal to JSON input. Sorry if it's terribly frustrating to watch me type. I am not the best typist. Okay. And then we want to read it. Oops. Oh, I just added a sentence. Okay. And then, so now that we've read in JSON string, and let me space these out just so we have a little bit more room. So now that we've read in the JSON string, we're going to create an input dictionary. We're going to do that by doing json.loads of this file, or excuse me, of the string. Okay, so now that we have this guy set up, we can print it out just so you can look at it. So now we have this dictionary. Oh boy, my typos are killing me. So now we have this dictionary of these values. Okay, so we've got the geometry, which is just specifying the file location. And so what we can do is we could actually go back up to the top, move this guy down. And what we can say is, now that we've got this input dictionary, we can say input dict, and then the key for that was geometry. Geometry. Okay. And so what we can do now is we can print out the same thing, and we'll see that we're able to access that file. Except for I've got a, oh boy, what was it? 241210_PTS. Okay. All right. So now we printed out this dictionary that tells us our free string velocity, our angle of attack, and our geometry file, and we've also read in the geometry file. So I'll comment that out and comment this guy out. Okay, so now that that's done, there's a couple other things I wanted to talk about Numpy arrays before I moved on to plotting. So with Numpy arrays, you can initialize them. So say we have, so what we can do, let's see. I'm trying to remember the name of the array, info. So what we can do is we can determine the size of info. It's called the shape when it's a Numpy array. So info.shape, and we're wanting, so I guess I'll just print that out so you can see it. Shape just tells us the sizing of that Numpy array. And you can do something similar with lists, but it's a little bit nicer with Numpy arrays. So this is telling me I've got 10 rows with 2 columns. So that means I've got 10 points, XY, that I'm worrying about. So what I can do is I can say, oh, I want to initialize an array with n indices, and that n indices is equal to info.shape of 0. So the 0th index of that tuple we just printed out. And you can look up what a tuple is. It's just basically a teeny tiny list in Python. So now that we have the 0th index of that guy, we know how many indices we want. We could initialize an array of, say, control points. And we can say, okay, I want Numpy Array, and I want to initialize it of all zeros. And I want it to have the size of n indices with 2 indexes. Theoretically, you want a -1 in there, but I digress. Okay, so now we've got this shape, and you can even put in a shape guy in there, or a shape specifier, but it knows what you're asking. And then, so we could print out CP just so you guys can see what that does. So that creates an array with one fewer rows than we had up here with the same number of columns. And we could even do info.shape of 1, and it creates the same array. Okay. And so now that we've got that guy, there's one really, really nice thing that I think is the biggest reason that you would want to do a Numpy array instead of a list. And that's because of element-wise calculations. And I'll keep this as part of this guy. So when we calculate things in a list, say we have a list of, let's go from 1 to 10. I believe that's 0 to 10. Okay, so now we have this this Python list from 0 to 10, and what we can do is, if we wanted to say add 1 to every single one of those indices, what we can do is we can say, okay, we have to go through for I in range, and then we have to go length of A. And then we can do add 1. We can add 1 to each index. So A of I plus equals 1. So this is just a way in Python for us to say add it to itself. And you can do something along the lines of times equals, there's divide equals, there's even exponent equals, there's minus equals. But yeah, and once again, Google is your best friend. Everything that you Google it's very easy to Google how to do things in Python, how to do things with Numpy arrays. It's pretty slick. And now we can print out A to show you what it's done. Okay, so we might not be able to do that. A of I plus, and now that I think about it, I might not be able to do this with a range. I might need to do this with a list. So let's just make a list. And then we'll do 0 through 10. Okay, so now we're going to go through each index and add 1 to each one. So we've done that. So, it wasn't terribly difficult to do that, but it's a little bit easier if we create a Numpy array. And one of my favorite things in Numpy is you can do linspace. So what we can do is we can say B is equal to a linspace array. And let's say we want to go from the value 0 to the value 10. And just like above, we want 11 points. So now we have this Numpy array, and we can add to it. But it's actually quite a bit simpler. So we can just say B plus equals 1. And now we can print out B in space. And now we can print out B, and notice it's already turned them into floats for us. So now we have this array, and it was just quite a bit simpler, right, to do that. So that, you do what you want, but Numpy arrays are very, very easy to work with. Let's see if there's anything else I need to talk to you about Numpy arrays. So once I guess I'll bring this up. So something that really easy, really easy to do with Numpy Arrays is we could say, well, you know, I want one array, so let's say B0 is going to be the array up to the nth value. So everything up to the final value. And then we can initialize B1 as everything but the first value. So if that makes sense, just explain that, guy. So B0 is all of these values, and now B1 is all of these values. And so what we can do is we can say, well, you know what, I have all these points, or all these values, and I need to figure out the in-between points, let's say. That means that I need to plug in, let's say C is equal to B1 minus B0. And so now I can print out C to tell us, to see what that looks like. What did I do wrong? Oh gosh, I didn't even tell it what array it was looking at. Heaven bless me. Okay, so now that we've done this minus, it told us the difference. So what it was doing is it's going through each element and it's saying, okay, B0 or B1 of 1, the 0th index is 11, and the 0th, or excuse me, the 0th index is 2, and the 0th index of B0 is 1. So it's just going through and doing 2 minus 1, 3 minus 2, 4 minus 3, and so on, until you get to 11 minus 10 for the final value. So you'll notice that it is one index shorter than this array up top, but that tells us the in-between values, if you wanted to call them that. And we could average, I mean, it's really easy to work with stuff, so we could average each array. So say we wanted to average the values between B0 and B1. Well, we can just do that by averaging them like this. So now we got B0 plus B1 divided by 2. And I'm doing this just to make sure it calls it as a float. And now it's averaged each of those points. So it said, okay, I've taken this point and that point, what's the average, or what's the midpoint between those two? And we've been able to do that for all of these values. Okay, so I think that pretty much covers what I wanted to say about Numpy Arrays. I don't know if there's anyone who's come in late who has questions, feel free to pipe in and let me know. Otherwise, I'm going to go on to plotting, and then I think we'll wrap it up. So when we plot in Python, let's see, let me start with an easy example. Okay, so when we plot in Python, it's pretty slick. Let's initialize it. I think I'm going to initialize it the better way. I have to remember because I have a hard time remembering this guy. Let's see. Okay, here we go. We're going to start by initializing it as axes equals plt.gca. Okay, and so that just initializes the plot for us. And so now what we can do is say we want to plot our info array way back up here, plot our airfoil shape. We can do that by saying axes.plot, and then we can put in the x values. So we just do that by saying, hey, I want all of the rows at the 0th column, and then I want all of the rows at the 1st column, and then we could plot it as blue dots. And we could even label it as airfoil. And this is the color, but I won't name it that. Okay, so now what we can do is we can, let's see, let me make sure I'm not missing anything. I mean, oh, okay, yeah, that's true. You can add labels, that X label, as X over C, and then we could even do the same for the Y label. And then we could, oh, that's true, so we'll need that. Okay, dot set aspect. So because this is a geometry, we want the aspect to be equal. In other words, if we're plotting this guy and we have one value in the X direction, we want it to be the same value in the Y direction, just so it doesn't look distorted. And we can do that. And then we can show the plot. And so we can run that real quick. And so what it's done is it's created this plot for us right here. And I might change it up just so it doesn't look like it has this box. Yeah, I think I will. So instead of doing this guy, we'll just say plot, and then X label for plot. And then this is axis. Plot. Okay, so I'm just going to show that again, just so it doesn't have that weird box around it. There we go. So now we can kind of see our airfoil, and you can see it's one of the ones that doesn't have a close trailing edge, so that's okay. So we've got this airfoil, okay? And then what we could even do is we could get rid of the dots and just look at it like this, right? And we could even, I'll go back up here and let's see what 2412 looks like with 200 points. So let's download this guy and we'll move it. .2412 with 200 points. Okay, there we go. And now, before we forget, we have to change the name of this guy in our JSON file. And so now it's going to plot this guy. Boom. Okay, so now we have the plot of an airfoil. And this can be helpful just to make sure that you're reading in your geometry correctly. Once again, I don't know whether he actually asks you to plot anything. Okay, so you do plot a couple things. I don't know whether he wants that in the code or not. You could definitely most certainly plot it in the code if you wanted. You could also do it in Excel. That might be something I'll need to talk to Dr. Hunsaker about, but I'd imagine he doesn't really care. Okay, so this is kind of crash course. I hope it was helpful. I don't know if anyone who's here right now has any questions. If not, well, I guess I'll just wait for a minute, see if you guys have any questions. And if not, we can call it a day. Okay, alrighty, that sounds good. That was long enough of a wait for me. Okay, so well, this will be good. We'll be. I hope this helps. I'll record this. Oh, we've got a question in the chat. Okay, perfect. Are Numpy arrays storing each X and Y value into a single point? How are they helpful again? That's a good question. Okay, let me share my screen again. So Numpy Arrays, what it is it's just creating, let's go down to where we made it, right there. Or we can even look at, you know what, let's go down here and we'll make another one. And I'll get rid of this plot. So Numpy Arrays are extremely useful in the fact that you are able to create, you're basically able to, so the reason why I like Numpy Arrays is because you're able to do calculations like this instead of having to go through element-wise and do it. I just think it's a little bit faster, a little bit easier for me to debug, where I don't have to worry about it going through each index. But once again, that's just personal preference. So say we wanted to create an Numpy array. Let's see, we could call it, no, I'm going to regret calling it something I can't even spell. Let's call it Sal. So Sal is our Numpy array, and we can create a list of zeros, excuse me, a 2D array of zeros. Let's say we wanted to have 5 rows, 2 columns. So now we have this array right there. So it's just nice just because we can do the math easier, if that makes sense. But what we can do is we could still go through each element. So we could say for I in range, and then we just say sal.shape of 0. And then we could run through each index of the, or excuse me, through each row. And then what we can do is we can run through each column, or we can, so this is through each row, and this is for each column in that row. And we could print out sal of ij. And this is one other difference between Numpy and list, Numpy arrays and lists, is that Numpy arrays, I can call it like this. If this were a list of the same shape, I would have to do something like that. People index out of range. Oh, yeah. I'll have to do that. Okay, so now it's just gone through and printed out each value that we had in this array for each I and j. And we can see it right there. I don't know, does that answer your question? Sorry, I just kind of went on a tangent. And feel free to unmute or whatever. Let's see, chat. Awesome, okay, great. Okay, if anyone has any other questions, now is the time. But I hope this was helpful. I mean, you do lists, do Numpy arrays. It might be a little bit easier, especially if you're new to Python. It might be a little bit easier to do everything in lists. I just find Numpy arrays easier.
Hey, I have a question.
For sure.
Sorry, I missed the first part. But what do you use, or like how do you download something to start coding?
That is a good question. I did go over it at the start, but it's probably something I need to go over anyways. So you're talking about, like, for example, this window that I have open, is that correct? Something like an IDE?
Yeah. Mm-hmm.
Okay. So there's several out there. Let's see. So if you guys have never worked with Python before, you should download Anaconda. Oh, interesting. I didn't know there was a movie. Cool. Anaconda Python. Okay, so this is a computer program. I'll go here. So you can download it. Product, individual edition. This is what you want. So what you'll do is you'll download it here. They have it for Mac. They've got it for Windows. They got it for Linux if you use Linux. So in Anaconda, it comes with, let's see if it that shows some of the programs. There's Spider. So Spider is a common IDE. I don't even know if I have it on this machine. I don't. But Spider is a program that you can use to work on your code. That's the symbol for it. So this just shows you some of the things that download with it. So matplotlib is the package I was using to plot up here. It also comes with JSON, it comes with Numpy, it comes with SciPy, it comes with Pandas, NumPy, all these different, and there's Numpy right there. It comes with all these different things that you can use to work on your code. And I believe Jupyter is actually even another IDE, I don't know. But go here, download Anaconda, and I would use Spider if you're trying to get used. Spider is a really great IDE if you're starting to work with coding, especially with Python coding. The one that I use is Visual Studio Code. It's also free. I still did download Anaconda, and that's just so I can have the Python compiler. So you can get that here. And you can get it for Windows, Linux, and Mac. There are others out there. It might take me a minute to think of them, but I would recommend Anaconda. So Anaconda, and then you're able to get Spider through that. And Spider is the IDE that might be best for everyone to use. Does that answer your question?
Yeah, thank you.
Okay, awesome. Yep. All righty. Any more questions? All righty. Okay, we'll end this recording now, and I'll post this up on Canvas so those who weren't able to attend can look through it and get a little bit of help on Python. So, all righty. Thanks for coming, guys.